So for point-slope form, we get the equation y minus y1 equals m times the quantity x minus x1. And our goal is to get this into slope-intercept form, which we should know is y equals mx plus b. Now what we're going to start with in point-slope form is a point and a slope. So we're going to take that point and slope and get it to our end product. So let's just pick one and see where it goes. We're going to have the point 3, 1 and a slope of 2. Now in the point 3, 1, we're going to think of the 3 as x1 and the 1 as y1 because those are the coordinates x, y. When I substitute them in, I get y minus 1 equals 2 times the quantity x minus 3. Now I'm going to simplify just using my algebra skills. Let's distribute first. I get 2x minus 6. And now I'm going to add 1 to both sides, and I get y equals 2x minus 5, because negative 6 plus 1 is negative 5. So there's an equation, y equals 2x minus 5, that would go through negative 5 and have a slope of 2. Okay, let's pick another one. But this time, let's say we only started with points. Let's say we had the points negative 4, negative 1, and 5, negative 3. So if it's point-slope form, we got a point, in fact we got 2 of them, we need a slope. So the first thing we need to find is a slope to work with. Now whenever you need slope, you can always use slope formula, and I'll add a link to finding slope formula. But what if we didn't want to use slope formula? What if we just wanted to figure out the slope? Now the slope is always the change in y over the change in x. So I went from negative 1 to negative 3. So that means it changed negative 2. I went from negative 4 to 5. That means it changed 9. So my slope is negative 2/9. Now, you use slope formula, you'll get there too, but that is my slope, negative 2/9. So I can go to point slope form. Set it up, and we get y minus, let's pick, we'll use 5, negative 3 as our point. And you could use negative 4, negative 1, it'd still come out the same thing. And our slope is negative 2/9 x minus 5. So I get y plus 3 equals negative 2/9 x. Then I have negative 2/9 times negative 5. I know that's a positive because it's a negative times a negative, and that's going to be 10/9. So now I'm going to subtract 3 from both sides, so it's still negative 2/9 x, but I need to do 10/9 minus 3. Well, what is 3 in terms of ninths? That's 27/9. So this comes out to be y equals negative 2/9 x minus 17/9. Well, besides the fact it's fractions, what this means is our y-intercept is negative 17/9, which is a little bit smaller than 2, because it would be 18/9. So I guess it would be a little bigger since it's negative. And we would go down 2 over 9 as our slope from there. Now, those are your basic using point slope. Let's take a look at that equation though one more time and kind of rethink what is actually going on. Where did it come from, or why can we so easily move it to slope intercept? So let's just take this and let's write y by itself. So I'm going to add y1 to both sides. And now if we think about slope intercept form, y equals mx plus b, it's not y1 out there, it's b. Well, b is the y-intercept. So for that to be a b and the y-intercept, we need the x value to be 0. Because when you have the y-intercept, so I'm going to make that x1 equals 0. So now it's x minus 0. So y equals mx plus b, which is our slope-intercept. So if you plug in and you solve through it, you're still kind of doing the same thing. You're still getting to that slope-intercept. It's just point slope gives you a nice form to start with. You plug in your point, you plug in your slope.